Well, hello everyone. Today we're going to be looking at scientific notation. And in scientific notation, it's a little bit different from what you've been doing. For example, in decimal notation, which is what we have here, you have a decimal point in your number, and that's exactly what the number is. And in this case, if you don't have a decimal, your decimal goes at the end of the number. So these are decimal numbers. Scientific notation, on the other hand, is a number written in scientific notation when it is expressed in the form of a number times 10 to the n, where n is your exponent, where 1 is less than or equal to that number, which is less than or equal to 10. In other words, the digit in the first place here is going to be 1 through 9, because it has to have a digit and then a decimal point. And the digit cannot be less than 1. So therefore, it can't be like a 0, in other words. And n is an integer, okay? In other words, the exponent here is an integer. And as you notice, here we have a positive exponent, and here we have a negative exponent. And we often go back and forth between decimal notation and scientific notation. If you look at this one, 3.45 times 10 to the fourth. This number 4 here, that is the exponent of the 10, tells you to change this scientific notation to decimal notation. The decimal is going to be moved 4 places to the right. So let's actually do that. 3.45, you move it 4 places to the right. 1, 2, 3, 4. So to complete this number, I have to fill zeros into those slots. So this becomes 34,500. In other words, 34,500. If we have a negative exponent on the 10, it means that your exponent is going to move to the left. So 2.35 is going to move 3 places to the left. 1, 2, 3. And again, you have to put those zeros in. So this becomes 0.00235. And we often put a 0 here in the tens place to indicate that there's nothing there in the units place value. So this is how you work with scientific notation. So we're going to look first of all at writing our numbers in scientific notation. So you're going to do several things with this scientific notation. First of all, you're going to learn to transfer back and forth between decimal notation and scientific notation, and then you're going to learn how to do problems with this scientific notation. And if you're in science, there are many, many, many things that use scientific notation in science. Really long numbers use scientific notation, and really small numbers like 0.000035. That would be put into scientific notation in many cases in science, okay? So, to write a number into scientific notation, what do we do? So, if we have a number such as 639 and a bunch of zeros after it. Now, to put this number into scientific notation, your first step is to put the decimal right after the first non-zero digit. So this becomes 6.39 would be your first part of the number. The second part of the number is count how many decimal places this is after that. 1, 2, 3, 4, 5, 6, 7, 8. So this becomes times 10 to the positive 8. Because to go from here back to here, you have to actually move the decimal to the right, which requires a positive exponent on your 10. Okay, now let's look at one that is not that kind. Again, the first step is to figure out where does your decimal go. Your decimal is going to go right here. So the first part of our scientific notation is to write this as 4.5 times 10. Now, how many places did that decimal move? 1, 2, 3, 4, 5, 6, 7, 8. Oh, it was 8 again. That's nice. But now, if we leave this as a positive 8, that means I'm going to move the decimal to the right to move it back to this, but that's not what's happening. The decimal has to move to the left. So this is going to have to be a negative 8, because that means to move back to a decimal, I'm going to move my decimal to the left instead of right. Okay? So that gives us basic scientific notation, moving from a decimal to scientific notation. Now let's work from moving from scientific notation to a decimal. So let's look at this. 4.9 times 10 to the negative 3. You're going to look at your decimal, which is right here. It says negative 3, so that negative 3 says you're going to move 3 places to the left. That puts a decimal there. So this is going to equal 0.0049. Let's look at another one. How about 4.9 times 10 to the 5th? This says you're going to move this decimal 5 places in that direction. So 1, 2, 3, 4, 5. That means you're going to have to put 4 zeros after that. So this is 4, 9, 1, 2, 3, 4 zeros. Turn and put your comma in for your place value. So this is 490,000. And that gives you how to do that, to move from, first of all, decimal to scientific, and then scientific notation to a decimal. Now we're going to look at what happens when we work with these scientific notations in mostly multiplication and division. The only way we would be able to add and subtract scientific notation would be if the power of the 10 was exactly the same. So we could add or subtract if we had 6.9 times 10 to the third plus 3.2 times 10 to the third. Since this part is the same, these have the same place value. So then we can add this and we can get 9 plus 2 is 11. 3 plus 6 is 9 plus that is 10, giving you 10.1 times 10 to the third. But that's not scientific notation now. We would have to bring the decimal back 1 place, making 1.01 times 10 to the first times 10 to the third, which equals 1.01 times 10 to the fourth. So this is the only way you could add or subtract, is if this power of 10 is the same on both of those. Whereas in multiplication and division, that is not the case. So let's look at some multiplication and division of this scientific notation and how we're going to handle it. So let's look at this problem right here. 3.5 times 10 to the fourth divide by 7 times 10 to the second. So what are we going to do? We're going to divide this part first. 3.5 divided by 7 is going to be 0.5 or 0.5. And this is going to be 10 to the what now? Times 10 to the what? Well, this is division, So I can subtract my exponents from your exponent rules, and 4 minus 2 gives you 10 to the second power. But is that in scientific notation? No, it is not. So what are we going to do? Oh, I put the wrong thing in. It's 35. That makes more sense. So 5 times 10 squared. And if we actually multiply this together, turn it back to a decimal, it would be 500. And in your assignment, this is the place where they want your answer to go. They want it to go to that 500. Let's see if we can get that clearer for you to see that 5. Is that better? Yeah, you can see it better now. Okay, so now let's look at another example. Okay. Now with a calculator, I realized that you could just plug this into your calculator and you would have your answer instantly. And that's often what we do today because our calculators are so common and that they're so easily purchased because their price is very reasonable. But let's look at this anyway. Here's another example. 15,000 times 0.25 over 0.0075 times 50,000. Well, the first thing I would do with this is change all these numbers to scientific notation. So if we do that, what do we have? 1.5 times 10, 1, 2, 3, 4 to the fourth, times 2.5 times 10 to the negative 1. And this will be divided by 7.5 times 10 to the negative 3, and then times 5.0 times 10 to the 1, 2, 3, 4 to the fourth power. Okay, notice I have 10 to the 4 and I have 10 to the 4. If I divide 10 to the fourth by 10 to the fourth, these two cancel. Okay? And then if I look at 10 to the negative 3 times 10 to the negative 1, that is going to, divided by 10 to the negative 1 divided by 10 to the negative 3, this is going to be minus negative 3, and then that's done. So this is going to give you times 10 to the 2, because negative 1 minus negative 3 is the same as negative 1 plus 3, which equals 2. So we've got our exponent done for our 10. Now what do we have? We have this times this divided by this times this. Well, let's see. What if I take 1.5 and 7.5? Well, this would be 1.5 goes into 7.5 5 times. So this is 1. I simplified that fraction. How about 2.5 and 5.0? Well, 2.5 divided by 2.5 is 1. 5.0 divided by 2.5 goes in 2 times. So this gives me 1 over 10. Well, what is 1 over 10? Well, this would actually be 10 to the negative 1, because 1 over 10 is equal to 0.1 times 10 squared. Well, 0.1 needs to be changed to 1.0 times 10 to the negative 1 times 10 squared, giving me 1.0 times 10, which is equal to 10. So as you can see, if you're doing it without a calculator, a lot of times moving it into scientific notation can simplify the task for you. This is exactly what you're going to be doing with your scientific notation.